Okay, let's have the example 23. The smooth circular log is supported by two identical frames of a sawback, one of which is shown in the figure. Each frame supports a load of 90 newtons and rests on a smooth surfaces. So determine the reaction at A and G, the stress in member BF, and the pin reaction at C. So this is the figure, and since there are two frames, one is shown and each frame supports a load of 90 newtons, so therefore that's the net load for this one frame here. Let's call this angle theta, which is also equal to that angle there. So for member BF is a two-force body because the weight of member BF is not included. So the force is directed from B to F or from F to B, and the weight is 90 newtons. So because this is 90 by symmetry, we have smooth surfaces, so each normal reaction at A and G would be equal to half of 90, so 45 newtons. So let's have the angle. Tangent theta is 400 because this 250 plus 150 is 400 mm divided by 300. So theta is 53.13 degrees. Then let's draw the free body diagram of the portion of the lag portion. So we have contact points at D and E. They are equal in reactions. Then we have weight, then reaction at E and reaction at D, which forms an angle uh, and D on the vertical theta also. So remember that the angle of inclination is also equal to the angle between the normal and the vertical. So we have the normals and this is the vertical, so that's why they are equal. Summation forces y equals 0, so 2nd times cosine of theta, cosine of 53.13 equals 90 newtons. So solving for ND is equal to NE equals 75 newtons. Now let's draw the free body diagram of ABCD. This is this. We have 45 here, FDF, and we have in reactions at C, horizontal and vertical. And we have the 75 newtons, which is perpendicular to the axis of the member. Then at C, we have this angle, we have this vertical distance 133, and that is theta, mm. So if we sum up moment about C, we can solve for FDF. So we have CX and CY at C, of course. And this distance is 133 over sine of theta, distance CD. So these are the distances. That's also theta. So summation of moment about C equals 0. Counterclockwise positive. So we have FDF times 250. Then minus 45 times 300. Then distance. So minus 75 times this distance. This is 133 divided by sine of theta, because sine theta is 133 over CD. So CD is 133 over sine theta, sine 53.30. So solving for FBF is equal to 103.88 newtons. And for CX and CY, summation versus X0. So CX, 103.88 plus CX, and plus 75 sine of theta, 53.13 equals 0. So Cx is negative, so meaning we assume direction for Cx is wrong, so it should be leftward. Summation versus y equals 0. Then 45 plus Cy minus 75 cosine of 53.13 equals 0. So Cy is 0. So therefore, the reaction at C is 163.88 newtons. So that's the reaction at C. That's it.